There are some general tips and guidelines when you're doing integration by parts. A common acronym is LIATE. Um, you can use this for choosing what you want U to be. In order, check the integrand first of all, is there a logarithmic part? Remember, you can't take the integral directly of log. So if there's a log of x in there, you probably want this to equal U. Next, come down and check, are there inverse trig parts? Next, check, are there algebraic parts? This is a good place when you have x squares or x to the fourth. What about trig parts? You can take the derivatives of these, you'll eventually get it. It won't go to zero, but you'll eventually get it so that you can add the integral from one side to the next and do some algebraic manipulation with the integrals. And the same thing with the exponential part. Now here are some tips for integration by parts. Suppose you have x to the n times either e to the ax, sine ax, or cosine ax. In these cases, let u equal x to the n. And then dv is the trig part or the exponential part. The u's you'll be able to take the derivatives of these down to zero, and you can integrate these easily. Now, what if you have x to the n times log, arcsine, or arctangent? Now, the derivatives of log, arcsine, and arctangent are algebraic equations, or they involve x's and square roots and that sort of thing. So in this case, you want the log, the arcsine, or the arctangent to equal u. And then you can take the du's. You can't integrate log, its arcsine or arctangent, with the skills we've discussed so far. Now, if you let that equal u, that means x to the n has to be your dv. Now, these you can integrate these. The powers will keep going up, and it will get very messy. But you'll be able to do the integration by parts. Now, what do you do when you have the integral of e to the ax, sine bx, or cosine bx? Well, in this case, just go on and let u equal the trig function, and dv equal e to the ax, the x. It won't go down to zero, but you will be able to do algebraic manipulation.